This is the answers to pages 421 and 422 homework from Unit 12, Lesson 4. Number 1 is choice 4. Number 2, choice 1. Number 3, A, the probability of rain given snow is 0.2 repeating, or the fraction 2/9, or the fraction 4/18. B, 0.3 repeating, or the fraction 1/3. Number 4A, 1/4. B, 3/4. C, probability of multiple of 4 given even is 2/4 or 1/2, or the decimal equivalent 0.5. And the probability of odd given greater than 2 is also 1/2. And they are equally likely. Number 5A is 0.34. B is 0.16. C, the probability of Chicago given takes the train is approximately 0.27. Probability of takes the train given lives in Chicago is approximately 0.56. And it is more than twice as likely that a person who lives in Chicago will take the train to work than a person who takes the train to work lives in Chicago. Number 6, the probability of A times the probability of B given A is equal to the probability of A and B. Number 7, the probability of B given A equals the probability of B. So given A has occurred does not change the overall probability that B will happen. Now the explanations. So again, if you know all your answers were correct, you're good. You can go on to the next or today's assignment. Or if there's a particular question maybe more towards the end, then you can just kind of fast forward the video and get to that question. Okay, so yeah, number 1, this is just the definition. Probability of B given A is going to equal, okay, so the given A is in the denominator, so the probability of A is in the denominator, and the probability of B and A is the numerator, which this is also the same as probability of A and B, so choice 4 here. B and A is the same as A and B. Number 2, so 468 are in Algebra 2, 292 are in Physics, and 180 are taking both. What is the probability they are taking Physics if we know they are in Algebra 2? So this is Physics given Algebra 2. So the total number in Algebra 2 would be the denominator, which is 468. And the numerator would be Physics and Algebra 2, which is the 180, which is 180 over 468, which is approximately this, which matches choice 1. Number 3, 18% chance of snow, 12% chance of rain, 4% chance it will rain and snow. So we want to calculate the probability of rain given snow. So the denominator is the probability of snow, which was the 18% chance, which is 0.18, and rain and snow is the 4%. So 4 over 18, or 2/9. But please just don't leave it as a decimal within a fraction, meaning don't leave this as 0.04 as 0.18. Please do change it to either the fraction 4/18, where your numerator and denominator are integers, or reduce it, or an equivalent decimal. probability of snow given rain. So here, probability of rain is the denominator, which was 12%, 0.12, and snow and rain is the numerator, which is 0.04, which is equivalent to 0.3 repeating. Number 4, so first you've got to know what your perfect squares are and what a prime number is. So for the numbers 1 through 8, the prime numbers are 2, 3, 5, and 7. 1 is not prime. So I kind of went around the circle here and had O for odd, 1, 3, 5, and 7, and then had E for even, 2, 4, 6, and 8. And I think this PS is for perfect square. Perfect square is 1, 4, and that's it. And I use PR for prime. So prime is 2, 3, 5, and 7. Right, those are the prime numbers. So probability of perfect square given even. Even is the denominator. The number of even is 4. And perfect square and even is the numerator, which is simply just 1. The number 4 is a perfect square and even, so that's only 1 out of the 8. So 1/4. Probability of odd given prime. So the denominator is 4, and odd is, odd and prime is 3, 5, and 7, so that's 3. 3 out of 4. C, what's more likely, getting a multiple of 4 given spun an even, or getting an odd given spun a number greater than 2. Okay, so first probability, a multiple of 4 given even. Well, even is, there are 4 of them. So denominator is 4. And multiple of 4 and even. Multiple of 4 and even. So that would be 4 and 8. So that's 2 of them. Let's put 4 and 8. They are multiples of 4 and even. So a half. And the probability of odd given a number greater than 2. Okay, so the denominator is the probability of greater than 2, which is 3, 4, 5, 6, 7, or 8. So that's 6. And again, I know I'm saying probability greater than 2, but you know the number 6 is not a probability. Okay, it would really be, I'm going to put this in pencil, it would really be 6 out of 8. And then probability of odd and greater than 2, well, greater than 2 and odd is your 3, 5, and 7. So that would be 3 of them out of 8. So it's really, we've got this what's called a complex fraction of 3/8 over 6/8. And since these denominators in both the numerator and denominator are the same, they could just divide right out, and your answer is 3/6. So 3/6 is equivalent to 1/2. So these are equally likely. Number 5, the probability that a person picked at random would take a train to work, given that they live in Los Angeles. Okay, so our denominator is the total in Los Angeles. So we're just looking at Los Angeles here. So that's what the blue arrow is pointing to. Just looking at the total for Los Angeles would be the denominator, 0.35. And of those 0.35, how many took the train? 0.12. So 0.12 divided by 0.35 is approximately 0.34. B, probability, they live in New York City, given they drive a car to work. So given they drive a car, so we're only looking at this, and the total for car is 0.31. And of these, how many live in New York City? Well, 0.15. So excuse me, I think I said 0.15, 0.05. So 0.05 over 0.31 is 0.16. And C, is it more likely that a person who takes a train to work lives in Chicago? So, or more likely that a person who lives in Chicago will take a train to work. So probability live in Chicago, given they took a train to work, is denominator's train, which is, let's see if I can get up there, yeah, the green here, right? So the denominator is 0.51, and the numerator is Chicago and train, which is Chicago of the 0.51 who take the train, 0.14 live in Chicago. So 0.14 divided by 0.51 is approximately 0.27. And now probability of they take the train given that they live in Chicago. Okay, so we're given that they live in Chicago, so we're only looking at those who live in Chicago, which is the purple here, indicated by this purple arrow. So the denominator is 0.25, and of the 0.25, how many take the train? And that's 0.14. So 0.14 over 0.25 is approximately 0.56. So it's definitely more likely that if a person lives in Chicago, they take the train to work. Number 6, solve this for the probability of A and B. Okay, so we have the probability of B given A equals the probability of A and B divided by the probability of A. Well, if we want to get the probability of A and B by itself, right, we'll get rid of division by probability of A. So I multiply both sides by probability of A, and you get probability of A times probability of B given A equals probability of A and B. And number 7, we say two events, A and B, are independent if the following is true. The probability of B given A equals the probability of B, and likewise if the probability of A given B equals the probability of A. Interpret what the definition of independent events means in your own words. So if I'm just taking this, so given that A has occurred, does not change the overall probability that B will happen, because the probability of B given A is equal to simply the probability of B.